Hello. In a previous video we discussed the ROC curve and we showed how to create it using the Excel programming language and how to also prepare the data using SAS. But now we're going to talk about how to do this in the R programming language. Again, this is not a programming class, but it would be nice if for people who are either managing teams of analytics analysts or working alongside to have some familiarity with the R programming language. So I'm going to walk through how to do a ROC curve using R. Now what we're going to do with starting off is we're going to use a somewhat of a scaled down version of the R program that we used in Unit 4. So we're going to use the same data set as before, and again, if we're going to do a logistic regression, we're going to load in the mass library. We're going to load in a data set, and let's just print off the first 6 and the last 6 records. So let's do all that stuff. This is something we've done before, and just to recall, we loaded in the mass library because that's going to allow us to do logistic regression. We set the path to where the file was located, and this was the data file, and you can download that again if you haven't already. You set the working directory path, and we're going to read in this data set, this guy right here, and it's a comma separated file. And if I print head, and I'm reading in this file and dumping the data into this data set right here, S data. So that's going to be my sample data set, and I'm going to call it S data. So if I print the first 6 records, you can see this first guy is bad, he didn't pay us back, and this is his loan, and his loan amount, his mortgage, his value, etc., etc. And then the tail prints the last 6 records. So now that's something we've done many times in this class, but now we're going to do a logistic regression model, and this one is going to build the logistic regression model using all of the variables, and I'm going to call this model m.all. Why am I calling it m? I'm just going, this is the convention I use, is that my models all have m dot and then something. I can name it anything, and I'm just going to name it m.all. And let's just summarize this guy and see what we got. And when I did a summary of this, it says that these are my coefficients, and here's my AIC value for the model. So this is the model that I've developed, and now the next thing we're going to do is do a backwards selection. So I'm going to do a stepwise selection, and I'm going to give it my model with all the variables. It's going to be a backwards selection, and these are all the variables that we are going to work with. So again, this is something we've already talked about in previous videos, but at this point I have removed, what did I remove? He removed the number of credit lines and the years on jobs. So now we have the best model that we can get with this data using a backwards selection. So this is where we're going to begin the process. What I'm going to do now is I'm going to copy my data set into X. So I've now created a new data set called X. And it's just an exact copy of S data. And again, it's usually a good practice before you do anything to your data set to make a copy of it. So if I screw up X, I can always get my data back. So I'm going to copy this into X. Now what I'm going to do is something that we've done before. I'm going to add a new column, and I'm going to predict the probability that somebody's going to default on a loan using both my models. The first one I'm going to use all of the variables, and the second one I'm going to use just a backwards selection. So let's put both of those guys in there. And if I did a head command here, you can see I've got my model exactly as we had it before, but now I've got two new variables. I've got my predicted probability of default using m.all, and I've called it pm.all, and that's the predicted probability of default using the m.all model. And the m.backwards model, if I did a predicted for this guy, this is the probability of default. So they're very similar models, so of course the probabilities will be very similar. So this is our starting off point. Now we're going to do some rock curves. Now how do we do that? Well, the first thing we need to do is install the library ROCR. So let's do that first. Well, if you ever want to install a library in R, you come over here to the packages and you click on this, and you have to set a crayon mirror. This is where the files are. There's a lot of these guys out there, so you click on set crayon mirror, and up comes this window, and now you have to tell R, okay, which file repository are we going to download this from? It could be any one. They all have the same files. However, they ask you to choose a crayon mirror that's closest to where you live. So I live in Ohio, so I'm going to click on some more of these things. And I live in the USA, and I live in Ohio, so we're going to choose this one. So I've now selected a mirror. And this is where we're going to download the files. Now I come up here, and I'm going to install a package. Now I have to install, and you only have to do this one time. So I have to install ROCR. So I look for that, and a little bit further down, and here it is. So I'm going to install this, and you only do this one time, and after you've installed it, you should never have to do that again. However, once you install it, you do have to always call the library function if you're going to use it. So I'm going to tell R that we want to install this library. So I've installed it, and sometimes you get a little more warning message that says, hey, listen, this version of Rock R was built on a slightly different version of R than the one you're using. That's generally not a problem, but it does give you that warning. So now that we've done that, the following commands, and I'm not going to go through them, but they will generate a rock curve and plot them, and also this AB line is going to give me this diagonal line that I can use for, remember how in the Excel file we had a diagonal line that represented randomly pulling names out of a hat. So this code right here will generate a rock curve. And so I'm going to generate a rock curve using the model m.all. So this is when I used all of the variables. So if you decide to use R to build your own predictive model, or to build your own rock curve, you can just copy and paste this code in, and the only thing you really need to do is, you'll notice that the only thing I have to give as an argument to make this unique is the variable pm.all. Remember, pm.all was the probability using the m.all model. So this guy says there's a 44% chance that this guy's going to default on a loan, and in fact he did. And this is a 72, and he did. Number 5 here, there was a 44% chance, but he didn't default. So I just have to give him this variable. Other than that, I don't have a lot of work to do. So let's just do this. Copy, and we're just going to paste right there. And so there you see it. We have the rock curve as we've seen it before. Now it looks, of course, a little different than the one that Excel prints out, but this is essentially it. And so you can see that if I had a cutoff value of 0.2, in other words, everybody who's got a 0.2 or better, we're going to assume they're going to default on a loan. If I do that, just eyeballing it over here, that's going to give me about a true positive rate of, oh, I don't know, 75. And my false positive rate would be about 20. The other nice thing about it is I can calculate very simply the area under the rock curve. Now, that means that the area under this blue line is 84% of this square. And remember, the bigger this number, the more accurate is your model. And we can do the same thing over here with my backwards selection model. So remember, we've created this variable pm.backward. If I go up here, there it is. This is when I did the backwards selection. And then after I did the backwards selection, if you recall, I created this new variable, PM backwards, and I predicted using M backwards the model. And I just scored my data set and created this new variable. So there we have it. So anyways, let's create a new rock curve. And it will look very similar to the old one. These two models are very similar to one another. So this curve is very similar. And we can also do an area under the rock curve. And it should be very similar to the first guy. So this has an 84.0. This has an 84.1. So there's the difference in accuracy between these two models is probably 3 or 4 decimal places in. And so they're very similar to one another. If I had to choose between which one I would use, I'd probably go with this guy, not because he's more accurate, because the accuracy differential is almost trivial, but I would do it because he uses he uses less variables. There's 2 less variables in there, and my personal preference is to go with a very simple model. So any model that is simple is the one I would like to go with. So anyways, this is how you would do a rock curve using the R programming language. And that's it.